Now I'm going to move on to part E of this problem number 25 in terms of what is the interquartile range of the reaction time. So first of all, let's just look at what is interquartile range. Whoops, let's get a pen color. IQR. And I like to think of it in terms of my box plot. I just have a little box plot. I know this right here is my min, and then this is my first quartile, which means 25% of the values are between here and here. This is my median, so another 25% are between here and here. This is my third quartile, so another 25% between here and here. And then this is my max, so my last 25% of values are between these two spaces right there. So this is Q1 and this is Q3. And so if we look at the percentages, Q1 again represents 25% of the values, and Q3 represents 75% of the values. So between the two, between 25% and 75%, we have 50% of the values. But this is telling us something very interesting. So I'm looking for interquartile range in terms of a normal curve. Well, it's telling me I want to have, let's get a different color. It's saying, well, how about under my normal curve, what represents my 25%, and over here what represents 75%. In other words, I know that my mean on my normal curve is always going to be 50%. So I want to know 25% this way, and I want to know 25% that way. And if I also just kind of remember my normal curve, I know that between this distance, this standard deviation 1 negative and 1 positive, I know that there is 68%. So each portion of this is 34%. So I knew that my 25% was going to be less than 1 standard deviation to the left, and that my 75% was going to be less than 1 standard deviation to the right. So I know right in here is where my interquartile range is, but I don't know what those cutoff figures are. I don't know, I mean, I know a whole standard deviation to the left is 1.32, and I know that a whole standard deviation to the right is 1.67, but I'm not going a whole standard deviation. I'm only going part of a standard deviation either way. So how do I figure that out? Well, I know this is one z-score, and that would be 2 z-scores. I'm going to be between 0 and negative 1 z-score this way, and 0 and 1 z-score this way. So I need to find out what is the z-score in here. So to do that, I'm going to use my inverse normal, because if I know what percentile I have, it will give me the z-score at that percentile. And I know what my percentiles are. My percentile is 25% for the lower range of my IQR, for my Q1, and it's 75% for my higher range of my IQR, for my Q3. So let's look at the calculator. Let's find out what is my inverse normal. That's number 3 for 0.25, my Q1 value. And it's going to tell me, it's my z-score. So let's write, I'll make a little line here for my 25 percentile, and I'm going to say my z-score for that is negative 0.674. And let's kind of go again and do the inverse normal again. Whoops. Second vars, 3 inverse normal, and I'm going to do this time for 0.75 because I have to turn my percentages into decimals. And lo and behold, it's positive. Whoops. Whoa, come on. z for this is equal to positive 0.674. And it's not surprising that one's positive and one's negative, but it's the same number because I'm going 25% this way to get to 25%, and I'm going 25% that way to get to 75%, right from my median of 50, and I'm just trying to find the exact same distance, which is 25 percentiles, from my mean either way, so it's not surprising that they're just the opposite numbers from one another. Well, now that I know my z-score, let's use my formula. Z equals y minus mu over standard deviation. Can I find out my z-score with this information now? Well, I know my z is negative 0.674. I don't know what my y is, that's what I'm trying to find. Y minus, I know my mu is 1.50, and I know that my standard deviation is 0.18. Let's give ourselves a little room here. Let's do the math now. I'm going to multiply both sides of my equation by 0.18 so that I can then cancel out my denominator here, but I have to multiply this side by 0.18 here. So 0.18 times negative 0.674, well, negative 0.674 times 0.18 equals, that equals negative 0.121. So I'm left over here with y minus 1.50. I'm going to add 1.50 to both sides of my equation. So I'm going to get my y value on this side is equal to, what would that be? 1.39. Let's do it on the calculator since I'm as helpless as everybody. 1.5 minus 0.121. Let's call it 1.38. It's equal to 1.38. That is the value right here, 1.38. So the reaction time for my lower boundary here at my 25 percentile is 1.38 seconds. Well, we can do the same thing now on the other side. We know that our z-score is equal to positive 0.674. So that is equal to, what's our y value? We don't know, but we know that whatever it is, if I subtract the mean and I divide it by the standard deviation, I'm going to get that'll be the z-score. So I have 0.674 is equal to y, which is my unknown, minus 1.50 divided by 0.18. Let's do the same math over here as we did on the other side. We'll multiply this side by 0.18 so we can cross off our denominators, but we have to multiply this side also by 0.18. Point 674 times 0.18. Positive, what a surprise. positive 1.21 is equal to y minus 150. Let's add 1.5 to both sides. I'm sorry, this is a, that's a 0.121. Let's add 1.5 over to this side. I am going to get y over here, and that's going to be equal to add 1.5. That is equal to 1.62. So my value for my third quartile is 1.62. Well, a lot of writing on this thing right now. But what I do know is that my Q3 value is 1.62. My Q1 value is, sorry, let's try and write it a little bit more neatly. My Q1 value is equal to 1.38. I take Q3, I subtract Q1, (1.62) minus 1.38 is equal to 0.24. That is my IQR.